follow-up of the completion of the cone clutch for the Little Giant power hammer. Our previous video shows the manufacturing of it, of how we completed it. When we first started this project, we had picked up this power hammer, the 50-pound Little Giant, and I had literally found that in a blackberry patch. After recovering it, there was no cone clutch assembled to the machine, and it was not available. I had contacted Little Giant, and a man by the name of Sid Sudemeyer, who owned the company at the time, was very helpful in telling me that he had drawings, he had molds that could be used to recast new parts. But in our investigation to follow up on that, it was going to be cost prohibitive to make get a casting made for us. So all of the components for this cone clutch are cast iron components. So, given my machining background, I looked into other alternatives after Sid had sent me the individual component drawings. And I found that by using mechanical tubing, which has a heavy wall thicknesses that can be of a variety of sizes, could provide the individual pieces that we would require to manufacture one through a welding processes and lathe turning. After acquiring those components, we followed up with the welding and the machining of all the individual parts, and we now have that as an operational piece. Total time that we have in manufacturing this was probably in excess of 80 hours. However, that could be reduced considerably by having a larger lathe. My lathe has a maximum swing of 14 inches above the bed. And given that our outside diameter was 14 inches on our largest component, that gave me a lot of problems on trying to be able to put together a tooling package that I could turn that. So there was a lot of very slow turning because of overhang and machining difficulties that way. So in a larger lathe, something that might be in the vicinity of a 16 or maybe even a 20-inch lathe, a lot of the machining time could have been reduced significantly. So I feel that probably with the welding and machining being done in a larger shop, then probably could get this piece done in a week's time without too much difficulty. There was, of course, a learning curve on pouring Babbitts. My partner in this project, Jerry Gallant, did not, neither one of us had any experience with pouring Babbitt. So that was our first, as you could see in our first video, we had a little difficulty with that. Things to take away from that is when you're going to pour the Babbitt bearing, the surface that you attach the Babbitt right to needs to be quite smooth, very smooth in fact, which allows the Babbitt right to really adhere to that. Because our first pour, as you saw in our previous video, leaked out and we had to melt the whole thing down, start all over again. But hey, it was a learning curve. We had fun. We're going to go ahead now and show you the component finished and operating on the machine. And Jerry's going to demonstrate the machine here at some point as well. Thank you for watching, and be sure to go back and look at our first video of the full manufacturing of the piece. Alright, we're going to show you the mechanism of the cone clutch. We're going to start the machine, and you'll see the outer barrel of the clutch spinning, and then this actually moves so when the operator depresses the foot treadle, which will push the spinning hub back into engagement on the wooden blocks. Okay, see how that's moving? When that happens, that transfers the power to the shaft, which operates the machine. We're going to show you that. We'll start the machine. We have this portion spinning, and now with the foot treadle being pushed down, this section is going to move into engagement of the wooden blocks and starts the machine operating. Depending on the foot pressure, how much slippage there is between this outer clutch and the wooden blocks here, so that you get very good foot control of the pressure of the hammer itself. So you can have a very light blow, or you can have it up to about 300 beats per minute.
And that noise
with full engagement.
That noise wasn't the hammer making that.
There we go. We're running. As he increases the foot pressure, we get full speed. As you back off on the foot pressure, you get the slippage between the cone and the spider, and you see how that works? So you got very good foot control, which is as the original equipment operated for those cast iron parts. See how that works? It's being working very well for us. We got a 1725 RPM motor. The operating speed of this at full speed on the original specifications is about 300 beats per minute. And we're at approximately a little bit less than that. I think we're somewhere in the vicinity with this shiv arrangement at about 250, which for us is fine, a little on the low end is fine. All right, we're back here on the other side of the machine, and we're going to show how the foot treadle actuates the clutch outer section there that's got the cone in it that picks up the friction on the wooden block. When the foot lever is depressed, this mechanism that is all homemade moves this portion into engagement to the wooden blocks of the spider. And then as you move that back, you can see that only moves very slightly. It doesn't require an awful lot of distance for that engagement. This is all home manufactured. Again, some of our fun forging projects as we were completing this restoration. All of this mechanism here, all homegrown to make it operate. This is a very close example to the original equipment. So some of the earlier machines that hadn't been electrified, this would have been a flat belt drive from up overhead on the line shaft. But these machines have been electrified, that have been rehabbed. Some motors are located up high here. We located ours down low. But those are all things that dependent on who's doing the restoration. But it works very well.
Alright, we're going to do a quick demo here just to show you how this all works. We got a forge fire going here. We're heating up a piece of metal here, just a half-inch round saw, which I've already pre-pointed the end on it. We'll get this good and hot, and we'll take it over to the power hammer and draw that out a bit just to show you how it all operates. By the way, we're up here in Cadescate, Maine. It was 3 above 0 this morning, so this fire feels quite nice. As you see, that gets pretty hot in there. Here we are, we're going to come over there and knock some of the slag off it. Pressing the foot pedal down. As you can see, we can control that speed of that onto that metal piece just by lifting up on the pedal a little bit, or work it a little faster. Saves a lot of work on the arm. Before you go back in the forge, it's always a good idea to get everything semi-straight again by slowing that down. There you go. Draws it right out nicely. Well, this is a shop. This is Cannon Blacksmith, Smithy here. This is a homemade forge chimney. This is all stone that come out of my pasture down back, and took one winter and built this. The stove over here is a railroad station stove, come out of this railroad station in Bangor, Maine. The shop was built in 2010. Everything you see in here took me about 2 years to build it all, slow process. And plus over here, which we just talked about, the little giant power hammer. This room was dedicated to it. The slab that this hammer is sitting on here, as you can see, is separate from this cement slab. This slab here is 2 feet deep and is separated by wood around this centerpiece to the slab that's out here. So when this hammer is pounding, it's dedicated to this one slab here, so it's not going to split and shank the whole shop when it's going. So that's one thing you got to consider when you're mounting one of these hammers, is to get yourself a dedicated slab so that it's just pounding on that one slab and not your whole building. Because they do have a lot of force when they're coming down.